Hi, everyone. Welcome to the Microsoft IoT Deep Dive. Today, we're going to deep dive into how you can secure your IoT deployments with SQL Edge and DxOdyssey. So I'm excited to be joined here by Sia, who's a peer here at Microsoft, and OJ, who is from DH2I, which is one of our partners, to talk about SQL Edge and DxOdyssey and what we're doing here. And so, hi, Sia.
Hi, Pamela. How are you?
Doing great. Do you want to talk a little bit about what you do here and what you're going to be talking about?
Of course. First, thank you so much for having me here. Hi, everyone. I am Vasiya Krishnan, and I work as a program manager with the Azure SQL Edge team. I'm so excited to be talking about today's topic, which is securing IoT deployments with Azure SQL Edge, as well as DxOdyssey from DH2I.
Yes, thank you so much for taking the time to talk to our audience and give them this overview. And then OJ, I'm really excited to have you here as well. Could you talk a little bit about what you do at DH2I and what you do on your team in DxOdyssey?
Well, thanks, Pamela, and hi to everyone. Hi, Sia.
Hi.
So my name is OJ Nicole. I am one of the IT guys here at DxOdyssey company. We are a group that are providing solutions for applications such as SQL Server. We specialize in high availability disaster recovery and network security solutions. So as my honor, privilege to hang out with Pamela and Sia to go over the security requirements and implications when deploying IoT solutions. So
yes,
will be a good one.
Yes, we'll have a lot of fun. Okay, perfect. So my name is Pamela Cortez. I will be your moderator today. I sit on the Azure IoT team. I am a developer, I'm an advocate, I'm a trainer. I play a lot of different roles within the Azure IoT product team. So I'm excited to be here today and bringing in these amazing speakers. All right, so let's go ahead and jump into what we're going to be doing in this session. So, with the explosion of data on the edge, security is really the biggest challenge facing modern IT departments today. So in this deep dive, you're going to learn about how security is made available with Azure SQL Edge when it's combined with DH2I DxOdyssey. First, we're going to discuss the security that is native to Azure SQL Edge and within the network of IoT Hub and IoT Edge. And then we're going to talk about how to secure that data as it moves outside of the Azure IoT Edge network, such as to other IoT devices or offline servers with the secure tunneling of DxOdyssey. Finally, we're going to demonstrate the security of a complete solution of Azure SQL Edge and DxOdyssey. So today, we're going to demo how a patient's ECG data is constantly monitored, and then how that patient is in a remote location with, not the best internet connectivity. They don't have access to a primary care doctor. So we're going to talk about that scenario. Sia is going to be going over it, and I think it's an incredible demo. So I'm excited for us to jump in with that. All right, so let's jump into the first part. When it comes to IoT really refers to those billions of physical devices around the world that are now connected to the internet. They're all collecting data and sharing this data, and the amount of data that's being generated is large and it's continue to grow. So I love this number that we're seeing here on the slide right now. By 2025, 75% of enterprise generated data will be created and processed on the edge. When you think about data, a lot of people will process that data on the cloud side, but we're seeing this huge trend of people being able to process on the edge and keep that data on the edge before they set it up. You can imagine the amount of data that's going to be generated on the edge side. So we need to be able to think about security both on the cloud, but primarily on the edge side as well. So I'm going to hand it off to Sia. Sia, when we think about organizations who are interested in these IoT deployments, what are the top security considerations that they should think about when creating these IoT deployments?
That's an excellent question, Pamela. So 97% of the customers that we spoke to have security concerns when it comes to implementing IoT solutions. And if we look at the graph on the slide over here, we can say that approximately 50% say data privacy and network level security are key. And then another 40% state securing endpoints for each of these IoT devices is an important consideration, given that these devices are not always connected to the cloud. They're located in different places, different parts of the world, and they're constantly collecting data. And they can be open to security attacks and threats. And security is extremely important when it comes to implementing IoT solutions. And one of the UK fashion retail customers that we have explained, any big brand out there or themselves as a big brand, they tend to be a big target, and hence securing customer data is very important to them. And security for these customers span across multiple pillars. So you start with physical security, you have technical security, you have architecture security, etc. And with this, you can see that it is an important area for many customers to invest in. So as a result of digital transformation efforts, most enterprises will have more application services and data that is outside their enterprises than inside. So this actually ties up with the fact that 75% of the enterprise data is coming from the edge by 2025. Yeah. So when it comes to security of IoT devices at the edge, one needs to consider perimeter security. So perimeter security is securing access to the edge compute resources, and this can be done through firewalls, access controls, encrypted tunnels, etc. The next thing that we briefly touched upon is application security. So beyond the network layer, edge compute, devices actually run applications that must be secured. The next thing is threat detection. So as edge computing is by definition not centralized, these devices are located across the world in different places. So it's very critical for providers to employ proactive threat detection technologies to identify potential issues earlier. And then the next thing is vulnerability management. So these are both known, there are both known and unknown vulnerabilities, and all of these need to be constantly monitored as well as managed. And finally, patching cycles. So devices come from different generations and different versions. So automated patching to keep these devices up to date is important for reducing the surface area of a potential attack. So when you look at all of these 5 points, they together come and give us what we call as a zero trust network architecture. So the purpose of a zero trust architecture is to address lateral threat movement within a network by leveraging microsegmentation and granular perimeters, enforcing based on data, user, and location. So this is also known as what people usually call, which is never trust and always verify principle. And that is what in short form is called zero trust. And the benefits of implementing a zero trust network architecture is actually immediate. So you have services applications that are brought within the ZTNA network or ZTNA environment that are not visible to the public internet at all. And if they're not visible to the public internet, they are shielded from any type of attack out there. So there is significant benefits in user experience, adaptability, agility, and also ease of policy management. And then all of this brings together scalability and ease of adoption, which is very, very important when already existing industries are trying to move into an IoT landscape.
Thanks, Sia. And I'm really curious, I know you're going to jump in, but I wanted to let the audience know that we do have a lot of security IoT white papers too online that we'll link at the description, and then also in the chat too if you're viewing and asking questions live. So I just wanted to throw that out there, but thank you for that overview of the security considerations. Would love to learn more about Azure SQL Edge, how it's generally available, and some of the capabilities there before we jump into DxOdyssey.
Yeah, definitely. Azure SQL Edge is a new product. We launched about a month back during Microsoft Ignite 2020. So before I dive deep into the security features that Azure SQL Edge brings to the table, I thought this would be a good place to talk a little more about this product and what it does. So Azure SQL Edge has been developed keeping the challenges of IoT in mind. It is a database that is optimized for IoT and edge deployments. So Azure SQL Edge is built using the same SQL engine that is present on Microsoft SQL Server and other Azure SQL offerings. And it provides the same industry-leading security and performance. And this Azure SQL Edge database can be deployed on devices ranging from IoT devices, as you can see over here, up until edge servers. The one thing that we need to keep in mind, especially when I say IoT devices, is it requires a minimum of 2 cores and a few gigs of memory. And this whole solution is a containerized solution, and it is compatible with most Docker container engines out there. And it runs not only on x64 architecture, example being your Intel or AMD devices, but it also runs on ARM64 devices such as your Raspberry Pi. And when it comes to developer and tooling experience, we are ensuring that it is consistent across your Azure SQL Edge, your SQL Server, as well as your Azure SQL. And the next thing is Azure SQL Edge actually supports connected, disconnected, as well as hybrid scenarios. And in the connected scenario, Azure SQL Edge is deployed as a module of the IoT Edge device or IoT Edge runtime. And in a disconnected scenario as well, Azure SQL Edge can be deployed as a standalone container. All right. So Azure SQL Edge is based off of Microsoft SQL Engine. That's been established now. And it brings with it a set of new features that's tailored to meet the demands of processing data at the edge. So let's take a look at the different features which are unique to this particular product. So time series, data streaming, and AI built-in. So the first thing that we are going to be talking about is native data streaming. So SQL Edge includes native support for data streaming, irrespective of whether it's on the cloud or whether it's in a disconnected environment. So what happens here is we support data streaming to and from multiple input and output targets. And this is the same engine that powers Azure Stream Analytics. And currently, in a connected scenario, we support streaming through IoT Edge Runtime, IoT Hub. And for disconnected scenario, we support Kafka clusters. And then we are constantly working on improving the source and target pairs that can be used for improving the streaming capabilities to and from Azure SQL Edge. The next thing is time series. So it's twofold when it comes to Azure SQL Edge. We bring to you already existing time series capabilities found in Azure Stream Analytics, such as windowing, aggregation, anomaly detection, checkpoint, etc. And we have also added capabilities to the SQL engine around time series specific functions and storage optimizations. And then this brings me finally to ML capabilities in Azure SQL Edge. So we support Onyx runtime, and Onyx is Open Neural Network Exchange. And what happens over here is you or the customer can first train their ML model with a framework of their choice, and all you have to do is convert that model into Onyx format. So once it's converted to Onyx format, it can be deployed on Azure SQL Edge and use the inbuilt native scoring capabilities. And what we're trying to achieve here is build your models on the cloud or data centers and deploy it to the edge. The next thing that's over here is native data movement. This also answers a part of your question, Pamela, regarding the data that is there on the edge what happens to it after all the analysis is done. So when it comes to IoT, not only do you need to analyze or engineer data on the edge, you also want some form of a long-term data storage capability when it comes to data. And data can actually be moved from the edge to your destination, which could be either a cloud target or your own on-premise data center, either through the streaming layer or by batch processing. And we actually support various Azure targets such as Azure SQL DB, Cosmos DB, etc. And Azure SQL Edge as a whole currently supports bidirectional data movement. And next thing is the choice of platform. And I briefly touched upon this already when I said we support multiple device architectures out there, ARM64 and x64 based architecture. And then you can also choose either a Windows or a Linux based device and host, and then use Kubernetes or Linux Docker containers to orchestrate your device infrastructure for better efficiency and automation. And then finally, when it comes to architecture, you can run it either in a connected, disconnected, or hybrid to support various edge environments out there. The final thing is unparalleled performance and security. We will be definitely diving deep into this. So when it comes to performance, we have actually taken all those features that made sense to SQL on containers, especially around fast recovery, column store indexing, and compression. And these have been enabled by default. When it comes to security, let's kind of dive deep into it. So security for Azure SQL Edge is across 4 main pillars, as you see over here. So one is platform and system security. So the platform for Azure SQL Edge includes a physical Docker host, the operating system on the host, and the network systems connecting the physical device to the applications and clients. So implementing platform security starts with keeping unauthorized users off the network. And this can be done through firewalls, encrypted tunnels, ensuring proper access control is applied, specifying and restricting host ports, and that's something that we are going to see in some time. And then the next thing is authentication and authorization. So authentication is the process of proving the user who they claim to be. So in the case of authenticating in Azure SQL Edge, we provide the same SQL SA login that is across all of Microsoft SQL offerings at this point. And then authorization refers to the permissions that's assigned to a user within a database in Azure SQL Edge. So it determines what the user is allowed to do once they are in the Azure SQL Edge database. So you have role-based access control or attribute-based access control privileges over here. Then you have database object security. So when you look at database concepts, you have something called principals and securables over here. So principals are individual groups and processes that are granted access to SQL Edge. And securables as a whole comprises of servers, databases, and objects the database contains. So each has a set of permissions that can be configured and also help reduce the surface area that is exposed to attack eventually. And then finally, you have application security, and security best practices are available for Azure SQL Edge, which includes writing secure client applications. And then there are SQL security features that are built in for Azure SQL Edge. And to start off with, we have what is the creating a login and a database user. This is very basic. So once you create a login and database user, the next thing that you want to do is access controls. So this is something that we just touched upon, which is role-based access control and the attribute-based access control. And that access control is necessary so that certain people access only certain parts of the database and not all of it. And that's very, very important when it comes to securing your data and ensuring limited access. The next thing that we are going to be looking at is configuring row-level security. So row-level security enables you to restrict access to rows in a database based on the user that is executing a query. And why is this feature useful? It is useful for scenarios like when you want to ensure that customers can access only their data. For instance, if you are looking at a banking scenario and the customer wants to access their account details, it makes sense that the customer can access only what he or she is attributed to or assigned to, and not the entire list of all of the customers that's there in that particular bank. So that's where row level security plays an important role. The next thing is enabling dynamic data masking. So dynamic data masking enables limited exposure of sensitive data to users, such as an application by fully or partially masking certain columns. And finally, what we have is enabling transparent data encryption. So one threat to your database is the risk that someone will steal the database files off of your hard drive. And when you have all of these IoT devices sitting in remote locations in a factory or even on a submarine, this could happen. And this could happen with an intrusion that gets elevated access to your system. And what TDE does is it encrypts the data files as they are stored on the hard drive. And then the key for this, the encryption key is then stored in the master database of the SQL Server database engine. So that database engine can manipulate the data, and only a few people have access to that key. And the existing database files on the remote devices cannot be read without access to the key.
Yeah. Oh, go ahead. I was just going to make a comment that is definitely a top of mind challenge that a lot of our partners and developers out there are facing, is that how do they protect those AI models? How do they protect the data that's coming in? I was working with an autonomous vehicle company, and they were training and doing all this video and getting all that data into the devices, but then they ran into regulation issues about, hey, how's the data being stored on this edge device? And are you protecting this data? Because if someone gets access to this device, are they able to see people's, faces and all the video that was captured? Are they going to be able to, take people's data, personal data that's on these devices that were collected? So there's a lot of things and regulations that are happening in local governments too in this area of how you're protecting the data on the device side.
Yep, I completely understand that from a customer's point of view and also from a regulator's point of view. Customer data privacy is key. And while Azure SQL Edge brings with it security and compliance features, and Azure IoT, IoT Hub, and IoT Edge as a whole has this entire IoT security solution, there is still a chance of data leaving the network and going and sitting in a place outside of your network. So when we look at security at the edge, deploying Azure SQL Edge containers with DxOdyssey software is a potential solution that enables security at both the perimeter and the application level, which is bringing us closer to the Zero Trust Network Architecture guidelines. So OJ, why don't you take over and explain more about DxOdyssey and what DxOdyssey is doing in this space?
Absolutely. Thank you, Vasiya. Wow, that was good. The descriptions on SQL Server Edge, and I just want to reiterate what Vasiya just went over there. SQL Edge, essentially a SQL Server engine, things that we use to we know and been working with for many years. So the security for Edge, for SQL Edge more particularly, is always protected and secure within the device, on premises or in the cloud, right? Device, you have SQL Edge running, it's built in with all the security features that Vasiya mentioned. Now, when it comes to data leaving the Edge device, leaving SQL Edge, and or coming in from outside, security, external security we're looking at, perimeter security is what we're looking at or thinking about. It's actually very important and something that we all have to be very careful about and be mindful of. And obviously, Pamela and Vasiya have touched on that already. External access, external data transfer must be protected. VPNs, what we consider legacy technology, is essentially a technology that allow access to hosts or networks, and that's it. So when you set up VPN, you open up your devices, you open up your network. So for us security guys, we always look at it as a security stack or network stack. You carve up a slide of your network to allow things to travel between two endpoints. That's all good and fine if you can guarantee those two endpoints never breach.
Mm-hmm.
If you get a breach on one end of the equations, more than likely, it will spread onto the other side. Because remember, VPN is about open up a network stack. Open up a hole to let two networks merge into one. Not really an ideal solution for IoT deployments, right? Like Vasiya and Pamela mentioned earlier. These edge devices, IoT devices, can be disconnected and travel remotely, distributedly across the entire world. So that's really very difficult to put together VPN solutions that allow you to span at any moment in time. And don't forget, when it comes to VPN, it's about the appliances, specialized routers that you have to put in on both ends of the equations to allow that network to be flow through. So VPN, SD-WAN is similar. It's extremely complex to configure and manage, and costly. Because once again, it's required dedicated appliances or routers to allow that to happen. Another one, when it comes to securing or allowing access externally or remotely, is opening up your ports. Open up your public port to allow data to flow in, flow out. Wow. This is actually a worse of the so-called security implementation, because you essentially opening up your device or your applications to the entire internet.
Mm-hmm.
Now, you can't limit some or restrict some access by implementing firewalls or various rules, but to do so can be very complex too, because these devices, these edge devices, the IoT devices, gonna move around. It's not gonna be on one network. It could be on any network, right? So all these so-called legacy technologies or solutions, they may work fine when you are confined into a well-secure data center or on-prems or on cloud. That's it. Anytime you have external data exchange in or out, it doesn't work anymore. So, DxOdyssey. DxOdyssey is a software-defined parameter solution. What it means then is it's a technology that allows you to secure your parameters. You define the parameters and then you secure it. And it's software-defined. Well, that means that it is a software-based. It means that you can take the package, you can take the solutions, install it on whatever device that you like or have access to, and you turn it into a secure gateway, allow things in and out at the application level. So unlike VPN, open up your network stack, your host for access, DxOdyssey allows you to confine it, restrict it down to a single app, single channel for a particular solution or application that you want to open for. So it's app level security. And because of that, you really have the control of what allowed to be in or out of the entire environment. There's no open port, there's no dedicated appliances, there's no dedicated routers, anything like that at all required for the DxOdyssey. So, and one more thing, the DxOdyssey in itself, similar to the SQL Edge, supported on x64 or ARM64. So Raspberry Pi, once again, any appliances essentially, any desktop, any OS can be used to deploy this DxOdyssey technology and turn it into a secure gateway to allow only particular apps to flow through, and that's it.
And
go ahead. I'm sorry.
Oh no, I interrupted you. I'm sorry. Okay. I believe you already answered this question. We had a list of top questions that we get from folks when it comes to this integration, and one of them is, do you have to have that open, dedicated port to allow access externally? And you answered it. You said no.
No.
I just want to double down on that.
That is really the key here. Is that most technologies out there require you to have a dedicated port. Whether it's a 443, which is an SSL port or HTTPS port, or some sort of a specialized port open on both ends, and they have what they call a controller sitting in the middle to referee data between. But see, such technologies like that work, however, because you have a controller sitting in the middle. Well, we call it a man in the middle. That means if you somehow get your controller compromised, your entire deployment, your entire infrastructure completely ruined. DxOdyssey does not require open port on either end. In fact, that's exactly what it's designed for. It's allow you to take your device, your application, put it behind your private firewalls, and never have to have a dedicated public port open. Yet, DxOdyssey still allow the two sides to communicate, or multiple sides to communicate. That's the beauty of DxOdyssey. And also, DxOdyssey technology does not require a controller sitting in the middle. So once the devices or the application connected to one another, connect to one another, they talk directly to each other. And there's another key thing about DxOdyssey is that it's actually taking your TCP application or communication, transport it over UDP instead. Now it's going to be asking me, why would you do a TCP to UDP and then back to TCP on the other end? Because remember, the client and the basic applications, the end user and the server that hosting the data talks on TCP. Yet data flowing through the DxOdyssey network or the solutions as a UDP. Well, the reason we're doing that is UDP is a lot harder to capture and steal data. And not just that, UDP is faster than TCP. So by design, UDP is faster than UDP. So when we transmit data over UDP, we gain performance, and then security, because there's no port open. And even if you're able to capture some data, UDP data, there's no way for you to stitch it back together, because by design, it's not ordered.
So do you have limits on how many tunnels you can set up then?
Oh, good one. No, the technology allows you to create as many tunnels as you need. And essentially you create a tunnel for each app. And you open up for one app, then you only have one tunnel to deal with, or configure, I should say. And if you have many more apps that you want to allow the data exchange, then you create a tunnel for each of one of those apps. But there's no limit on the number of tunnels you can create over the DxOdyssey gateways.
Okay, wonderful. I have two more questions before moving on from DxOdyssey. But talking about tunnels again, how does remote users who are outside of the local network connect to those tunnels then?
Aha, good one. So do install DxOdyssey. Like I said before, it's a software solution, so you can basically install on any device. You install the software and connect them together. They will be able to find each other over the cloud matchmaking service. So again, matchmaking service, that's exactly what it stands for. And it's cloud-based, so it's highly available. Again, it's deployed throughout the world. So as long as you can connect to one of the regional or localized matchmaker, if we do a matchmaking for your forums, and the nodes will find themselves through the matchmaking service, and they will travel, obviously again, the data travel over UDP, and we also employ DTLS as the means to secure your data on the wire. So even, again, first, UDP itself is hard to decipher, and now we also put the encryptions on top of that through encapsulations on top of that by using the TLS. And the TLS is similar to TLS on TCP. It's there to provide secure exchange between the two endpoints. So the TLS is being implemented to encrypt your data on the wire, and virtually anything that flow over this invisible tunnels is extremely difficult for anybody to hijack and or hack. Even if they somehow capture a package, there's no way for them to stitch the data back. So it's invisible. So for us, it's really an invisible way to protect your data. But to really protect your data on the wire.
Okay, wonderful. Thanks for spending more time explaining that. And then my last question before we move on is, does DxOdyssey, integrate with any other authentication tools?
It's just a tunnel. Once you create a tunnel, you have a tunnel. So any kind of the authentication that needed, for example, SQL Edge, it has its own internal authentication and authorizations method. That's still intact. We do not change that. Remember, we built a private, secure tunnels you allow data to flow through. And the apps themselves have their internal security models, which continue to work as if they were local. So,
wonderful.
It works with anything.
Okay. Thank you, Sia and OJ for going through and spending more time and deep diving into that. So I'm excited to see kind of an architecture of this before we jump into the demo.
Absolutely. All right. So what we have here is a simplified edge deployment. We have sensors that are collecting the data and published to the edge device where SQL Edge is deployed. And of course, with SQL Edge there, we'll be able to do local computations, organizations, processing of the data locally on the edge. That's the beauty of SQL Edge, right? In the past, you would have your sensor data collected on the edge and then shipped somewhere for processing and then shipped back. That's a two-way for each processing and how long it takes to process on the other end and how long it takes to get back. And remember, these edge devices or IoT devices are considered mobile devices. Therefore, connectivity is not always guaranteed. So if you require data to be shipped out from processing, the ship back before the damn sensor can do anything with it, that's really a waste of effort and energy and resources. Yeah. So having data processed locally by SQL Edge is the beauty. And of course, once you have data processed, you definitely want the needs to move this data outside of the edge to, say, the external portals, auto apps, or business intelligence, the technology or solutions to analyze or further and or present the data to the end user of the other processes, or even go into the cloud or ship it back onto the on-prem data center for centralized collections and the final data analysis or trending. The legacy technology that we mentioned earlier can be used. Don't get me wrong, it can be used. However, as I mentioned earlier, the cost of implementing these legacy techs doesn't really provide adequate security for the IoT architectures or deployments because it's costly and you open up your network stack for possible intrusions. And if one side is breached, the other side going to be breached too. So you essentially can open up your edge and somehow move that into the data center. You definitely don't want to do that. So DxOdyssey can be used instead by only allow one tunnel for SQL Edge communication, and that's it. So remember, DxOdyssey is about application level security. It's there to protect the entire environment by only open up for the one application that you define. In this case, we have SQL Edge, shipping data in and out of the edge device. So
And
it's a
then-
lot more secure. Absolutely.
Yeah, and what happens if maybe what happens if DxOdyssey or Azure SQL Edge, one of the components fail, like either or? What happens in this scenario when they're working together if one of them fails?
Well, let's say the DxOdyssey fails. Well, remember SQL Edge is a local solutions that run on the edge device. It will continue to process the data.
Okay.
It will do whatever it's always been designed to do. Edge, it's just an edge. And DxOdyssey is simply think of the private roadway for data movement. If it unable to connect to the internet or unable to connect out, meaning it fails, right? Because there's no connectivity, then that's fine. It will sit back and wait until the next cycle. So by design, it will try to reconnect every 15 seconds. And again, that's all the user definable. How often you want to reconnect or retry to sync itself with another peer in the forum. So once you get connectivity back, and when I say connectivity, it could be any kind of connectivity, whether you connect to a Wi-Fi network, connect to a mobile wireless network, it doesn't really matter. It's just connectivity. So one connectivity is restored to the edge device. This Odyssey will reconnect with its peer and allows SQL Edge data to sync with its peers again.
Okay.
So it's there, it's to have auto retry, health monitor built in. So connectivity restored, it will reconnect itself. And you say SQL Edge somehow say the shutdown and the DxOdyssey is still running. Well, remember it's just a private, secure roadway. So it doesn't really hit the SQL Edge in any way. So if SQL Edge restart again, then it will pick up whatever is left off. Right?
That makes a lot of sense. Yeah. It's good to know that.
Absolutely. I mean, exactly. That's the reason why I think this is a very solid and fully secure solution. You have Edge, you have SQL Edge doing its local processing without basically taking the data, ship it out, ship it back, do all the processing locally on the Edge device. And then you have the DxOdyssey allow and guarantee the data transfer in and out of the Edge securely and privately.
Yeah, thank you so much for giving this overview. I think the demo will help showcase how those two work together when it comes to Azure SQL Edge and also DxOdyssey, and what are some of the kind of prereqs that you need to do before getting started working with the two and how to set it up.
Absolutely. Absolutely. So in this demo here, just a quick layout for everyone. We basically taking by deploying SQL Edge inside an edge device in Azure, and then we have a PC that running. Look at it as your admin system, and it's completely remotely disconnected. They are connected over the internet, essentially, right? There's no firewall, there's no open port. There's just two devices disconnected, and through DxOdyssey will create this private tunnel to allow the admin PC or device to connect to SQL Edge and read data, write data, and process data. So Sia is going to walk us through, and Vasiya and I walk us through and deep into the demo.
Got it. Thank you so much, OJ. So as we're seeing over here, what we're going to do is, for the purpose of the demo, we'll be analyzing ECG data for heartbeat categorization. So throughout this demo, there are 5 key stages that will be highlighted in the journey of our patient. So first is create. Create refers to the creation of patient-generated data. And so let me just open the create mode. So what you see over here is we have set up a simulated portable ECG monitor that is constantly receiving data from the sensors. And then that data is going to be written to Kafka clusters. And for the purpose of this demo, we are assuming that this patient is located, like he or she has this ECG monitor on them, and they are located in a place that has sporadic internet connectivity. So for sometimes they are connected to the internet and thereby can send the data to the cloud, which is always secure. And then for sometimes they are not connected and they are actually in a hybrid situation where they cannot connect to the cloud. So now that this data is being generated, it's being processed around, the next important thing is actually communicating that data. So in the case of chronic disease management or monitoring, streaming the data that is coming from all sensors to a single device is extremely important when it comes to making decisions. So you are going to make these decisions by taking into account multiple data points from the patient generated data. So as a next step, what we're going to see is that the data from Kafka will be returned to our Azure SQL Edge instance. As it is a remote deployment, we have deployed Azure SQL Edge as a standalone container on a portable ECG monitor. So let's jump into that. So this over here that you see are the T-SQL streaming constructs that is actually helping us write all the data that is coming from Kafka into Azure SQL Edge instance. And this entire Azure SQL Edge is on a standalone container on a portable ECG monitor. So the next two things that we are going to be looking at is essentially aggregating and analyzing. But before aggregating and analyzing this data, what we are going to see is how do we deploy a DxOdyssey a runtime IoT Edge module? And then how do we use that DxOdyssey to create a secure tunnel between these portable ECG monitor and the cloud before they're sending the data across? So in a moment, we will be opening we'll be opening the Azure portal. So if for the purpose of this demo, we already have a DxOdyssey for IoT that's running. Just to take our viewers into how exactly to deploy, it's very simple. All you have to do is go into your IoT hub and then go into IoT Edge and then go into set modules. And once you come to set modules, you take up the marketplace module. And then you have to type in DxOdyssey so this is where it is. All you have to do is just click on this. Once you click on this, it gets deployed as an Edge module. And once that is done, the next step would be is for you to set up the different environment variables over here. Essentially the host name, the password, the OTP, and the licensing and all of that. So once that is done, what happens would be is we move to the desktop client of DxOdyssey. So in a moment, we will see how that is done.
Well, thanks, Zia. So what we have here is a DxOdyssey admin console. It's run on this remote PC. And as you've seen here, there are two peers in this quorum. You have the PC, remote PC, and the DxO H1 module that Zia shown earlier was deployed in a container and the Azure Edge device. So if we look at the DxO H1 properties or details, you can see here all of the pertinent IPs and configurations between the two nodes. So the PC, if you notice, is sitting behind a private network. It's running on 192.168 address, and it's connecting out and able to connect to the edge device running in Azure inside the container. And it's also running in a private networking space, which is 172.18. And for those of you who do Docker, you should recognize that right there, because Docker is always stored at 172 private addressing. So These two peers, from our perspective, all it is nothing more than running DxOdyssey software, and they be able to connect to one another over the public internet through randomized external port. So from the outside, from anybody outside of this world, they very difficult for them to find these two nodes, because once again, we do not have any open port dedicated for communications whatsoever between the two. So nodes or peers, or the DxOdyssey node that we call it, or device, can find each other dynamically and connect each other directly and dynamically. So next we'll take a look at a tunnel that we have created to allow SQL Edge to communicate, to read data, to allow applications to read data from SQL Edge and or write data into SQL Edge. So what we have here, if you take a look at the definitions, in fact, if we let's take a look at the add tunnels features, it's probably a little more fun. I will walk you through that. Essentially, when you add a tunnel, you define the tunnel name, and then you define the target. And for us, obviously, we want to allow access to SQL Edge running inside a container in an IoT edge device. So you specify the destination target, in this case, DxOH1, and then the target IP or host. Well, we want this tunnel to be created for SQL Server Edge, running inside a container, running inside also on the same edge device. So we would specify the SQL Edge container name, and then the port that SQL Edge is listening on. And the origin basically saying, all right, you have a target defined, you have a destination defined, now you got to define the origin. Who is allowed to connect through this origins to get to SQL Edge? So what we have here already done on this particular tunnel, we define the PC. Only the PC can connect to SQL Edge. So the 127.0.01 is a loopback address, is a local address, only running on this PC. Any app running on this PC is allowed to connect to SQL Edge through this tunnel. So once again, DxOdyssey allows you to create a micro tunnel for a specific application. You define who is allowed to connect to and through the tunnel. So based on these definitions, we only allow the PC to connect to the SQL Edge running inside the IoT Edge device in Azure. So at the bottom there, you also see a little bit more details on what's going on with this particular tunnel. You can see the tunnel name, once again, the origin, destination, where it's going, it's hitting. So the application running on this PC will connect to the DxO Edge device, and then in turn, it will forward the request or data to SQL Azure Edge. And there is a single connections right now alive. That's why you see sessions there. It says all of the details information that you would need to know between the two devices. So there is a sessions open. It's connected on 127.0.01 on the, again, random board that connects to the Edge device, and then in turn forwarded to the Azure SQL Edge. And there has been so much data transfer and received. So all the pertinent networking details or specs is captured and displayed to you. So you control who has access, where this tunnel gonna go, and who gonna be the target.
Awesome. So thank you so much, OJ, for giving this breakdown on how to use the DxOdyssey desktop client and how to set up that dynamic tunnel and thereby access the Azure SQL Edge that we have deployed. So as a next step, we are going to be connecting through this dynamic tunnel and then access the data in Azure SQL Edge to take the data, push it to the cloud, and then do some kind of ML model training on that data, and then push it back into Azure SQL Edge device, and then run an inferencing on the ECG machine. So let's take a moment. First and foremost, let's look at the tunnel over here. So if I go in and if I look at how the connection is, if you recollect, just a little while back, we spoke about this local host that we have set up and the port that we are using to communicate with Azure SQL Edge. So this whole thing is connected through that particular server. That is the server details, and we are connecting through Azure SQL Edge using that tunnel. So once that is done, the next thing that we are going to look at is this machine learning model over here. So for the purpose of this demo, given the time constraints that we have, I have already run this demo a little. And what we see over here is first we are calling all the required libraries that's needed, such as the pandas and sklearn kits, and definitely the Onyx runtime, because we need to convert the model into Onyx before we deploy it into Edge. We set up the connection strings to read the database and get the data from it. Once that is done, the next thing that you see that we are doing over here is essentially upsampling the data. So in order to train your ML model, we need to ensure that there is less bias and there is equal representation of all the data points. And that is exactly what we are doing over here. And then we are actually using something called as the multi-layer perceptron classifier to train the model using this. So we are training the model using MLP classifiers. I have actually taken about 100 iterations. You can run it more than 100 iterations as well. The higher the number of iterations, the more accurate the score is. So for me, the model score is around 93%, which is good enough. And then I just run a couple of other scores, such as the root mean square and then the MSE to see if the scores are good. It's pretty good. The next things that we are going to do is essentially convert the model into Onyx. And once the model is converted into Onyx, we are going to be deploying it through the edge using this remote tunneling. So we spoke about analysis and aggregation. So all the aggregation is done, the analysis is done, and now we are deploying this ML model into the Azure SQL Edge to finally get to the solution. So let's do this. So what we're going to do is run this model. And for the purpose of this demo, we have taken about 10 latest points that we have. And we are going to look at these 10 data points, the latest 10 data points, and classify the heartbeat based on that. And from what you can see over here, the heartbeat is about classified as 1. Heartbeat is usually classified from 0 to 4. There are 5 stages, and it's at increasing levels of how fatal it is. And in this particular case, the last 10 readings that have come in is classified as 1, which means it is not that fatal. It is well within the normal ranges, and hence we are good to go. So with that, we come to the end of the demo. We saw how we are taking the data from the portable ECG monitor, accessing the data through secure tunneling, and then running ML models on this data in the cloud, and then sending that data back into, sending the trained model back into Azure SQL Edge, and then doing some kind of inferencing at the edge.
I love this scenario. I think this was a great demo, and it really puts it in perspective, you know, how you can use Azure SQL Edge and DxOdyssey in these type of scenarios and use cases. So if you're interested in learning more about Azure SQL Edge, you can go ahead and download the Azure SQL Edge data sheet. We have information on docs. You can even check out a demo on ARM container and streaming. You could read and follow our blog for more updates. And keep in mind, all of these links, I'll make sure they're in the description and in chat as well. So don't worry about, hey, I don't actually know what those links are and I can't get my hands on this PowerPoint deck. We will provide those links in the landing page and description. So I just wanted to say a huge thank you for Sia and OJ for being here today. It's been a pleasure seeing and working with all of you and hearing and getting to geek out. Is there anything you want to end with folks watching?
First, thank you so much, Pamela, and everyone who is listening to us and watching us. This was a great opportunity. I am super excited for Azure SQL Edge and for DxOdyssey. We both launched just last month.
Exactly.
Yes.
Both products just launched. We both went GA a few weeks ago. So
yeah,
pretty cool stuff. So you guys watching this, go to the portal, get the bits, play with it. It's a module. You can deploy it and yank it out if you don't want to.
Thank you everyone for watching. We really appreciate you watching. Feel free to add comments. If you have any suggestions for future deep dives, feel free to ping me on Twitter at AltaOhms with hashtag deep dive. But we'd love to hear all of your suggestions and feedback. So thank you so much. And we hope everyone's staying safe and has a great day.
you too.
Bye.
Bye-bye.